Today we are going to give our presentation on our computer network project, which is to plan the data center network for a university, which is this one. So we had to plan a large data center computer network that was to cater the needs of a university environment comprising of 15,000 users. So we are going to give our presentation on this. My name is Shahrukh Khan and my group partners are Talha Zahir, Abdullah Shah and Faizan Atif. Alright, so from the start we knew that many factors will have to be considered in order to ensure that the large network that we are going to implement will be able to operate successfully. And we know that a university cannot afford for its network to go down completely. I mean, sure, maybe at any point of time, some part of the network might stop working and might need repairing or replacement, but the entire network cannot fail since the successful working of the university highly depends on it. Therefore, we decided to build a large network consisting of multiple networks built on the star topology. So as we have stated in our report, we have chosen the star topology, multiple star topologies as the topology for our network. Okay, so when it came to deciding which type of network topology that we will have to use for our network, we made a list of all the network topologies that are available to us along with their strengths and weaknesses under the section network topologies in our report. So first we had mesh topology. Mesh topologies had quite a few advantages, but also it had many disadvantages that would make it unsuitable for our network. So such as the arrangement in a mesh topology is that every node is connected to every other node. So it's like a mesh, it's all a mixture. This leads to redundancy of many network connections. Also, a lot of cabling is required, which is why it leads to redundancy. So this network was not suitable for our university. It would make things more complicated. That's why we did not choose mesh topology. Then we also have ring topology, and the reason why we did not go for ring topology is because the failure of a single node in the network can cause the entire network to fail. So we cannot have this in our university setting because I mean, as I stated before, it's okay for part of the network to fail, but even if that part fails, the other part of the network, rest of the networks in the university should keep working. So we cannot have this at all. So that's why we did not decide to go for ring topology. Then we also had the option of using bus topology, but we did not go for it because the cable length is limited for this. So as we all know, university is a large place, so having this constraint would make it impossible to use bus topology. Also, this network topology can perform well only for a limited number of nodes. So we are trying to cater the needs of 15,000 users. So we cannot have this either. That's why we came to the decision that we're going to use the star topology as it was most suitable for our network. Why? Because of this point. Because adding or removing network nodes is easy and can be done without affecting the entire network. So this was the main reason why we have chosen this star topology, because as we all know, in a university, new students come in, all students, they graduate, they leave, and similarly faculty members come in and they leave. So there is constant adding and removal of networking nodes. So we need a type of network that in which this can be easy. So that's why we went for star topology. Okay, next we have the design. So yeah, we have stated here the types of devices that would be needed for the network. So of course we have network switches, we have network routers, modems, bridges, repeaters, and systems. The details are written in the report, so I just don't want to extend the presentation. So sir, you can read this yourself. And again, we have application services like electronic mail, file sharing, file transfer, instant messaging. So these are the essential application services and the types of devices that are there in pretty much every network. So we have stated those over here. So the tool for simulation, we have used Cisco Packet Tracer as the tool, and the networking devices that are involved in the topology. We have designed our server, router, switch, and copper. And in the simulation, we have shown a small subset of the larger topology, because we all know that data center for 50,000 people is not possible to show with this tool. So we have shown a small subset of the larger topology. And we have made use of TCP to avoid any loss of data. And rest, Abdullah will be presenting the simulation, which will come later on. But now I would like to call Faizan to continue with the presentation of our report. Thank you.
Assalamu alaikum. My name is Fizan Atif from Computer Network Section A, roll number 17L4281. In this presentation of data center planning, I will be explaining a topology of data center. So this is a topology I will explain in the Cisco Packet Tracer. So in Cisco Packet Tracer, there is a main router and a main server which connect to all of the subrouters. So the main router will be given a NAT IP address, and that will be visible to the entire world, and the routers within the subnetwork will have local IP addresses. So first we will be having a switch of 24 ports. So each switch will have a subnetwork which consists of 24 hosts. Another switch will have 24 hosts. So one router will have 3 switches, and one switch will have 24 hosts, so two switches will have 48. So if we calculate, we have selected we have selected 625 switches for the topology part. So 625 into 24 ports is equal to 15,000 users. So we are planning for 15,000 users of university. So this will contain 625 switches, and there will be 209 routers. So each router will be connected to 3 switches. In this diagram, it is connected to 2, but there will be another third switch over here. So we have selected 209 routers, and each router will have 3 switches. So we can see here that 209 routers into 3 switch. So it gives 627 switches. Two routers will have 2 switches. So this is the total quantity of the switches and routers, and each router will have a local server. So 209 routers, so the server will also be 209 servers, and this is the local server. So each of the router will have 3 subnetworks for each of the switch. It will have its own subnet, it will have own subnet, and third will have another subnet. So this is the topology. This is the multi-star topology. This is one star over here, and zoom out. This is one star, this is second star. If one server goes down, the local server will keep running all the hosts. If the main server goes down, the local will run. If local server goes down, the main server will keep on the host. So this is the entire topology. So next I will explain the quantity I have explained. Servers are 209, switches 625, routers 209. Copper cable depend on number of feet, and we will only use one IP address as we are using the NAT scheme, which is network address translation. This is the network address translation. The ISP has given us this IP address, which is given to the university, which will be visible to the entire world. And within the network, there will be local IP addresses. This is the unique IP address to the world. This will be unique to the local network. So the prices are taken from Amazon.com and local websites, other websites which are mentioned the references. The server rack is all $1,995, and these are the switch price, router, Cisco router price, copper price for 6 feet, and IP address will be charged 0.036 US dollars. So when we calculate multiply the price with the number of the servers and routers, so total amount comes out to be $4,93,593, which is approximately 5 lakh US dollars when we include the price of copper cable, which we have not included in this estimate because it depends on the depends on the length of the university. So this is the cost, and thank you. And next, Abdullah will present the working of the simulation. Thank you.
My name is Abdullah, and I'll be giving you a quick walkthrough of our prototype. As you can see, we've used a multiple star topology. There are 24 PCs connected to each switch, and then 2 switches are connected to a router. A local server is then connected to the router as well. This ensures that each part of the network is modular, meaning that even if a server that is higher up in the hierarchy dies, the lower part of the network will still remain functional. Now, in our network, in the proposed design of our network, we considered this whole thing to be a unit. If I zoom out right here, you can see that there are 2 units in this prototype, and then the 2 units are connected to a router, which is then connected to the main server right here. So now, of course, having these many local servers will increase the cost of the system a lot, but the local servers will also benefit the network greatly, as even if the higher parts, so even if the main server right here dies, the lower part of the system will still remain functional right here. This unit will still remain completely functional. So that was our reasoning behind choosing these many local servers. And that is also the end of the walkthrough. Thank you.